Hello, everybody. We will start a webinar in a few moments from now. Thank you. All right. So hello, everyone, again. This is Daniel speaking. And today we will continue with part two from good to great, how to write Milton post-processors. And today I prepared three very interesting subjects. And the first one will be about the standardization that I promised the last time. And there will be a lot of also codes today where I will actually show you how to implement the C-axis interpolation for milterns, and also how to implement the coolant options. Of course, this will be for the miltern machines with a more than one channel, but actually you can implement those coolants as well also on the milling machines as well. Today I will start basically with a few things to say. First, something about the recordings. So this webinar, as the previous one, is recorded, and you can find it in the two places on our website. The first place is basically into videos. Here you will see it. Sorry, my bad. So you go to the webinar here, and you will see webinar recordings. And then here you will have the latest webinars, and you will be able to find it over here, and you can download the video. Okay, so sorry, as I can see, you didn't see it. So basically, on the website, you will be able to go to the webinars over here, and then you'll be able to find webinar recordings. And over here, you will be able to find and download the video and the presentation itself. And also another place, it's you can find it also in the reseller area. Few things about the previous webinar is regarding to the few get functions that I've discussed, and in one moment I've said that the last two regarding to the axis limits and the home reference, those actually are completely defined in 2020 as well. So everybody who have today's version of 2020, they will be able to enjoy this function as well. Another thing is that it is still not implemented into the current version, but the online help file that you can actually, once you install it, the future version, I think it will come with another hotfix or SP, we'll see. You'll be able to find all those get functions documented, and I just want to show you where they are located. So you can go to the GPP tool commands over here, and here you will see, get function command. So we make sure that all of them are very well documented with the right example. And there is from the Solicam functions here, the most of them, I think all of them actually are coming with examples. So you can actually click here, and then actually you get the example as well. And at the bottom here, I will just go scroll down here. As you can see, they're all well documented as well. Let me go back, and also there are the latest one, get access and home reference. You can also find it here. All right, with that said, let's move on to another presentation, which will be about the writing standardization. Let me go and open like this. Let me swap the presentation here. Okay, so first of all, why I decided to show you this. First of all, why it is important is that we all get some standardization while we are writing, and I want to show you a very early stage of this webinar series, as this is, I think, very, very crucial. And first, why we need the convention, okay? As you saw within some of my previous in my previous webinar, I also used this convention, but I didn't talk too much about it, yes. But why we need it? So first of all, I just show you 3 different styles of writing the post. Most of here and there, they all do the same thing, but the way how it is written and how the variables are called and everything, the procedures makes it very, very difficult to later on, once the post requires the revision, to modify it, okay? So it would be very nice if all of us actually are speaking the same language in the terms of post-processor writing, right? So we needed to do this, and we did this like 2 years ago, just internally, just to see how this will work and how this will behave on the long term. And actually, it shows up that we can now say to all of you that you can use this convention. Okay, so I'll go with very yeah. Well, also, I hear what is very important: easier, effective debugging. I want to say also allowing sharing post-processor within developers. Yeah, and so far we didn't have any conventions. I think this is very, very important, especially when we're working in as a team. I think this is very, very important. All right, so let's start with a little bit very basic stuff. As you may know, all the variables in SoyCam we support 4 different types: the numeric, logical, integer, and string. Yes. And the way how we are naming user-defined one, it's with prefix that will be N, B, I, and S. And on the bottom, I just put some of the examples. What is very important, the start of the naming variable start with a capital letter. As you can see here on the left to up to the right, I just named something with for the numeric, logical, integer, and string. As you can see here, I have an expose, expose save. As you can see, every second is the capital as well. Then we have like logical first rapid or startup job, and as you can see, all of those examples. Now, there are examples where you couldn't make every single capital. Of course, another underscore is an optional. So you can also make like a B start off and then underscore job, or you can make like X2 pause. If you want to do like every second capital, it will be X2 and then P will be the capital, which is actually not that nice. In that case, you can just really do like N X2 underscore pause, okay? That will be also good to do. Let's go next. Let's go faster a bit. Also, what is very important, it's for the string formatting of the system variables should be defined without the prefixes. Also, not only as you can see here, apos underscore f. So there's no needs to define s underscore apos f. That will not make automatic formatting for your system variable. The same thing is for the user-defined variable. It's more complex. I'll try to explain you in a couple of more slides. For the local variables that are used in particular user-defined or system procedures, you need to put also the L. This is very valuable because once you read the procedure itself and you see the NL or BL, then you know that you cannot remove this one, or at least you know that this is located only this procedure. This is very valuable information, especially if you're writing pretty long procedure, okay? And here I just put some of the examples here at the bottom. So it's just nothing so special. Just if it's local, just put L. You've probably seen that I use this L a lot in a previous webinar where we have a lot of local variables to define. Let's go next. Yes, especially here, as I said, if you're using in procedure and as an argument as well, you need to declare that here as L, first axis angle and second axis angle. There are also the local ones that can be only used in rotated plane. All right. Also, very valuable information during the post-processor definition. I met many times a situation where I'm writing the array and I forgot to put the to curly brackets in order to define that it's an array, and it would never happen if I know that it is by adding the prefix next to the variable, like with a. Yes, so also here I just put an example what is happening if you have a local n array. In that case, you just put an LA, okay, or BL, LA, and so on and so on. And here I also at the bottom, I just put some of the examples. Yes, now the procedures. Nothing so special. I've seen many different types of user-defined procedure, but I think it's very important that we put some prefix before, and we decided that will be USR with underscore. And then you can write it with every single capital, basically the same style as for the variable. Nothing so special about it. Yes, but we decided that it will be USR. Now, something regarding to the MCO cycles and variables. I think this is also very good. It happened to me many times that I thought that this variable was not used anywhere, but then I realized that this particular variable was actually defined in my VMID or MCO cycle. So to see to distinguish it better, just put the MCO and then underscore, and then you just make the variable name itself. And here I just put here for the name of the procedure, the name of the cycle, you just say as MCO, and then so on. Yeah. Now, something about the VMID variables and parameters. As you may know, we have a lot of machine options. We have also for this here, it is a mistake. Actually, it should be VMID variable as we could. It will be also variable, same viable information as we have it for the MCO itself. And then we, as you know, we have the machine options. We have milling drilling parameters. We have turning drilling parameters, probe parameters. We have also for the miscellaneous milling and turning. And for those, we kind of split it as into MO, which is for the machine options with an underscore, and then you can type the drawing name, like a variable name. And then DM, like a drilling, milling parameters, DT, and so on. For the turning parameters here, we have T, TT, and TG. This is for the turning only. This is thread, and this is groove. Okay. And by this, it is so easily now to understand where this variable, when once you've seen it in GPP or from your colleague, it is very valuable because you know where this particular variable is defined. Is this a system one? Is it defined in VMID, MCO, or where inside the VMID? Okay, now very important question. As we now declare this convention, when we should start, use, when we should use it. So first of all, existing post-processor should be edited using, used format. So if you already have defined some of the posts, so it is written in very old style, or it's you should not change this format. Okay. Also, what is another option is that you can add, and when you are adding a new stuff into a post, you can start using the new new style. It will be big downsides if you downside if you go, you know, and just modify a bunch of your posts just because of the style. That will not make you money. Yes, so this is something that it's just for this is just international convention, and just modifying tons of post-processor without any effect is it wouldn't be efficient. Yes. I would advise that all to use this convention only for new post-processors. Yes. And also, if you have existing templates, then you just change it, the template itself, to the new format. Now, there is a very nice software that I will try to mention during the part 3 that can automatically convert your post-processor style of writing. Okay, so it will find the format, and it will completely change change it to the new format. Okay, I'll try to talk maybe even during this webinar. Depends on how much time we'll have. The next rule that we have is try to avoid calling the procedure more than third level. Yes, I know that this is pretty hard, but I'm just talking about the new post-processor. So if you're defining the post-processor, calling procedure in levels less than 4, it will be very appreciable, because then your colleague would have bigger chance, you know, to debug your post if it's necessary. Yes, so I would strictly recommend to not have so many subcalls of the procedure if it's not necessary. Okay. Especially this is important. Use tabs and spaces. The main thing about this, as the tabs and space, the difference is if you start typing the spaces here, like 3 spaces here, these 3 spaces are fixed. Now, the big advantage of using the tabs is that every single editor, serious editor for the post-processor, either that it's a Notepad++, every free software also can have a settings for the tabs. So you can basically change the tabs to 3, 4 spaces automatically, and the whole your post will look as ever you want. Yes. So just use tabs over here when you're defining the new block. Also, here I'm talking about hitting the enter or the spaces between something when you're declaring. I've seen many posts that they have no spaces over here. That's completely fine. I'm not saying that this is a must convention. It's still optional, but it's all about reading, improving the readability of the post. So it means that if I show you, you know, this procedure that has no enters or not spaces between, you will agree with me that this is a little bit harder to read the code. Okay, so the spaces between every if statement and every after each call will improve the readability of the post, even though that it will make your post-processor 10% bigger, but the improving the readability doesn't have a price. Okay. I said about the tab size. Every software basically have settings for this. Okay, so you should not be worried about that. And another rule: write your GPP on English. Yes, so the GUI name or general user interface name can be local language. So this can be any local language. That's not a problem at all. But the GPP name, something that it will be used in the GPP, write everything on English. So it's pretty hard if I define anything on my local language and then give it to my colleague. And then even no matter how good the post is, if it's perfect one, and even just if you want to change the header, he will find it very difficult to do it, if it's, especially if it's written in local language. This is also something optional. I will talk about this also during my cases with the C-axis interpolation. I will show you this. It's a properties of the Visual Studio Code. To once you're declaring the variable, try to put every variable within one line once you're declaring it. Of course, if you have a group of variable like center relative formatting, you can put for X, Y, and Z. So that's not a problem, yes. But for the specific variable, try to put a short description after it, because the Visual Studio Code has a very nice feature that can display this in like a pop-up window. Yeah, I'll show you that later also. And now something a little bit convention regarding to the VMID, not how to make a machine definition, but very important, it's how to define the MCOs. Okay, so every time when you're making the milling post-processor, the MCO cycles, by default, it's completely fine that it's completely empty for a milling. But for a mill turn, it's a little bit different story. And I tried to split the MCOs by three types. And we have the MCOs for the retracts, we have for the tool change, and the part transfer. Okay. This is very important. And on the left side of the picture here, I will try to show you what will be the default according to the kinematic. Now, what we have here, we have a chuck, and we have only the turning tools here and the two axes. Now, for this kinematic, the MCO cycles, as well for the one with the live tools and the C-axis, and here we have the Y-axis, the MCO cycles would be the following. So we will have two MCO cycles in the retracts, tool for the tool change, and one part release. This is very important, and I'll try to explain you what those MCOs are, and you will agree with me that this is very, very necessary. So if you have one turret, you will have a retract in X, and also if you have the Y-axis, I said if I have, because there is a machines that doesn't have the Y-axis. That's why I put it into in parentheses back to the reference. So it will, whatever you do here, go just back on X. And another one is just retro X and Y, but also to the Z. This Z, it's an optional because you can also go to the left and right limit. It's also a very nice option. This is about the retracts. Now we have a tool change. When you have a tool change, basically it will go X, Y, and Z. And if optional, if you have a B axis, it will go first to the retract and then the tool change will be performed. And another MCO, it's the same thing, except that you have also the Z preposition. This particular MCO, it's used for the cutoff operations, as you want to make a tool change, but you immediately want to preposition with a local work offset. And this will be very nice. So you change the tool and you go towards the part in Z direction. And then we have part transfer. We have only part release because we have no subspindle here at all. So this is very important. So for this basic kinematic, this is the 5 MCOs that you should have. Let's see next. So if you have a B axis here, as you can see, the MCO cycles are completely the same. So we are not changing the MCO cycles at all. The number of the MCO cycles are still the same. Here I just said a mistake. There is also like B also to the reference, but even though I think you can put this together with the second one, but just it's up to you. Yes. Now let me show you what is happening when you have a subspindle. There is a lot of things going on, nothing regarding to the retracts or either the tool change, but we have something about the part transfer. Now suddenly we have 5 more MCOs. And what these part MCOs are. So let's see. So the part catch, so catch part on main spindle and start synchronization on. So basically, we'll take the back spindle, go to the wires, the main, grab the part and turn on the synchronization. Now this is a default, so nothing more, nothing less. So we just go there and clamp it. Now we have another one in case the part is on the sub spindle. In that case, the back spindle will go towards the main spindle, and then they will be clamped as well. But it is part transfer towards the main spindle. Yes, so like vice versa. Now we have a pull part in main spindle. So basically, once you pull, once you are here, you can pull. Okay. So this very rare case, I didn't see any actually, that the mill turn machine have 2 bar feeders. So usually they have 1 bar feeder, which is either or main or sub spindle. And I think what I've seen in 99% of the cases, actually it's on the main spindle. Then there are 2 more, and it is regarding to the retract back spindle with part and also without part. So you are here, you've successfully cut off the part, and you would like to go back. Or there is a situation wherein you are clamped to the main spindle, you perform some milling turning operations, just supporting the part, and then you would like to go back without the part. So it's not a part transfer basically, yes. So these are all MCO cycles that you need for this particular kinematic. Now, either though you have this revolver with a B-axis, or if you have a second channel with another revolver or with a third revolver, nothing will be more changed except that we'll add the retracts and the tool change for the particular turrets. And here I just type here turret N, as it can be second turret, third turret, N turret. Will have exactly the same types of the retracts and also the tool change as I actually defined it earlier. Yes, so nothing more, nothing less. Basically with this is like first convention ever made in SolidCam, and this is actually how you can, so I talk here how to write a little bit here about how to write the variables, and also how to declare the variables inside the VMID, and also how to actually define the MCO cycles for the milling and also for the turning and mill turn machines with all various kinematics. Okay, I hope you like it. If you have any questions, by the way, you can always raise your hands, or you can chat me in the channel. You have the chat window there, so you can feel free to also ask any questions. Okay, nice. No questions so far, but I will stop it if there will be any. Now we will move to the C-axis interpolation. Again, I think this is very nice, a very nice topic here. I know it will be also pretty hard, the showing the coding online, it's pretty hard. Everybody would agree with that. Also showing some of the solutions, it will take time, so you need also, guys, to practice. Once I show you here all the codes, try it by yourself, after the webinar. I think it will be very valuable. And today I will not only talk about the implementation of C-axis, but I will also talk how to improve existing C-axis interpolation cycle that I found that it is used in, I think, more than 95% of our post-processors. Yes, and first, for all of you who never implement those kind of things, I would like to say a few things about this cycle. Okay, first of all, in this webinar, I will talk mostly about the FANUC-based cycles, like a Mitsubishi, like a Mazak, like FANUC itself, and I will not talk about Siemens one, which is I think completely the same, except that the code that it's transmit. And there's many sources where you can see 112, but in most of the case, it's actually 12.1. This is a phase interpolation. It means that the machine will use the XZC axis in order to perform the milling. Okay. Now, what is very important for you to know regarding to this cycle? Why the cycle actually exists? You should know that on most of the controllers, first, this cycle, it's not free. So it's something that customer have to buy as an option. Why have to buy? So why this cycle is anyway used? Okay, it is mostly used for the very large parts in diameter. Okay, when it exceeds the y-axis stroke, for example. And here at the end, at the bottom, I see if the part diameter or it exceed the y-axis stroke. Basically, you have no other options but to use the x-axis, z-axis, and c-axis to rotate the part in order to achieve, the surfaces of the part. Now, also here I put another example on the narrow linear turret stations, like a Swiss type machines. They have no other options but to use the c-axis. Otherwise, you can hit, another tool next to it. Yes. So this is one of the examples. Okay. Now, the question is why the people just, why the operators just don't simply, write the x, z, z axis as it is, and they will receive everything. Now, the problem is that x, z, c coordinates are pretty hard to calculate for each point. As you can see here, even if it's a straight line here on this, I'll call hexagon, even if it's a very straight line, for each point here, interpolated point, you need to add a new point in order to get a good surface quality. And depending on the interpolation, the better surface quality would be. Now, doing this completely, manually, it's not an option for the manual programming. Yes, so that will be, catastrophic. So the main advantage of interpolation cycles for a c-axis is that you can use arc interpolation G2 and G3. So like a normal drawing, you take it, you program it with specific format, and machine automatically knows, how to do this. There is also you can use the radius compensation. This is extremely important. If you're doing only x, z, c with clear coordinates, you can't use the compensation. And this is, in most of the cases, it would be not acceptable. So you must use radius compensation. Here I also mention XZY or XYZ programming instead of XYC. So I will talk about that, why this is like this. Also, the G code is much shorter if you have a cycle, because you have the arc interpolation. You don't need to use the linear interpolation, within the distance. So your code, it's at least, like 90% shorter. I think also one of the most important thing is that you're receiving much better surface quality. No matter how good tolerance you put, they will be fine, but never as with the cycle. The cycle will make it perfect. Yeah, and the last thing is that it is operator friendly for manual G-code programming and adjustments of the code. So for the operator, it is very nice that he can actually make a manual programming according to the drawing without no problems. And here I have an example of 12.1, and we'll try to analyze all together before I go actually into a code. First, here we have a simple square that we want to achieve with a square of 50 here, and the tool just goes within these lines. Yes, it is nothing so important. Here we have like tool call. We'll go to the milling mode. Then we will go to the c-axis 0. And this is very important for me to mention that you need to go to the C0, but not truly. I will also talk about that later. Then we will turn on the live tool. We will approach first in Z. Then we'll go with X, Y, and C. Now this C, in all examples that I've seen in programming manuals, they put C0. Okay. Now, none of the programming manuals actually mention that this C doesn't have to be a 0. Okay, so I'll talk about that in a few moments. Okay, this is just a simple first example. Then we are approaching to the working position of 20. So here we are going to the depth, and then basically turning on the plane. It can be different from controller to controller, and then turning on the cycle. And now, as you can see here, we are using the compensation here, and this time it's the right one. And basically, we are just going with a simple geometry here and just going exit. Now, what is very important here to see, let's see here, it's 25. Now, everybody will say, yeah, but the C-axis angle is not 25. The C-axis here represent actually the Y-axis. So if for the drawing, if you imagine here Y-axis, it will be 25. So it's a Y-axis coordinate. But if you type C here together with 12.1, he will actually automatically understand that and interpolate, to the correct angle. Now, nothing so special here. At the end, we're going with the G40. We're going out and then turning off the interpolation cycle. Few rules here that are not mentioned in this drawing. It is not possible to make G0 movements within the cycle. So G0 movements within the cycles are not allowed. So this is the first rule. Second rule that they are usually saying is that you must start with C0. As I said, this is not truly, this is not true. And I will show you, the example and advantages of this. And I will, of course, say the disadvantages of having it always on C0. Okay, this is a programming habits. So this is actually how the polar interpolation actually looks like when we define it in 95% of our posts. This is how it looks like. And this is nothing different than the one that I showed you earlier. But I would like to show you first a programming drawing that we will program here. It is a simple geometry here that I'm very frequently using when I'm testing my posts. And basically what we have here is just the geometry here that has the center here. In the center we have the half circle here, and then we have against half circle here that are equally in the center. And then we have another one that is a little bit shifted here. So I can see if I'm rotating, if my part is rotating in the correct direction, and if I'm getting, the right right image. Yes, if the angles are all correct. Here, just for you, I just put here the dimensions, so you can have a feeling what the profile size is. And then here's the toolpath. Now, in this demonstration, I use two things. First, I use the compensation, because the compensation, I will receive the geometry based on the geometry here. And also I have used here, the arcs. And it's very important that I test also the arcs. As you can see here, I have the G2 and G3 arcs all the time. So I have here clockwise, here it's counterclockwise, counterclockwise, clockwise, clockwise, counterclockwise, and so on. Let's analyze a little bit the code as well. So here we have like G28, H0 reference, then C0. So this is something that you've seen also in the previous example right from the manual, okay? Nothing so special. We are turning on the 12.1. Before 12.1, we are going with G01 F5000. I've seen many posts that have this, I will call fake feed, just in order to basically, as you know, as I said earlier, the rapids cannot be within the cycle, cannot be G0. So this G0 will be replaced by this feed 5000. Now, of course, it doesn't have to be 5000. It can be any other number depending from machine to machine and what customer actually like. Now, this is all fine. What we have here is preposition. First preposition, it's the opposite. Now, all of you who don't have a knowledge of what the opposite is, I'm recommending you to contact So I Can Support, and we will give you another webinar where we talk about these sets. Feel free to ask. Then we have starting polar interpolation, and then we'll basically start with the linear interpolation in H+set, and as well with the arc interpolation with H+set. Now we all know the H+set, it will generate the output based on the MAC or virtual MAC, getting it from the submachine. So basically, whatever you see in this coordinate system, so you will receive the code right from it. I have a question from Conrad. What is the main difference between post to machine? Yes or no? Conrad, this would be a question. I'll answer this question later on. Okay. Okay. Now this is a programming drawing. Now if I run this code on the machine, what will happen is the following. So first the part I'm talking here. So we'll get the C0. I will go to the preposition. And then once we hit the start polar interpolation, we will rotate, the part will be rotated according to this next movements, which is inside the move 5 axis. Now all this preposition stuff and starting the polar interpolation actually would be in most of the cases in startup job, okay? Now there is a few problems with this, guys. Also here I just mentioned that here we have the line 5 axis, arc 5 axis. There is also another here move 5 axis, but with feed 5000. And with inside the end of polar interpolation, we have end of job. Now there is 4 main disadvantages of this. As you can see, the coordinate system here rotated, and it will rotate all the time while the part is rotating. And the first thing is that preposition take unnecessary movements. So what is all about? As you know, that in this particular part, I have constant movements. Yes. So the constant movements, will be in most of the cases completely fine. But for example, if you want to make this line here first, and then second line here first, then third line here next, you will receive many rapids. Now, as I say, the rapids are not allowed, and you will need to turn off the polar interpolation. Yes, in these cases, machine will always go to the G0 C0 first, and this is the jerky movement. Now the customer would see, okay, the geometry at the end it's fine, but I'm receiving the jerky motions. Now FANUC fans, they know about this limitation and they hate it actually. Yes. Rapids are overwritten with the G1 F5000 in order to avoid turning off the polar interpolation. Okay, I hate that as well. Successively jobs will reset the C-axis each time. So this is also what I say, even if it's not within the job. So if you have another job that you want to do and another job that you want to do, and all of them are with the C-axis movements, every time you need to go with the C0, to reset it. You will all agree that you don't want to see that, yes? And also what is very common, that what I've seen in the support case is that when we have the 4th axis transform, it will always reset to the C-axis after each transform. So can you imagine that we have here only one single line over here, and I'm transforming it 4 times here? Just after each transform, he will always go, to the C0, then to the next position, and C0, then to the next position. You will agree, it's not something that you would like to see, and it's not nice to show it during the testing. Yes. Now, how to avoid this? What I prepared here, it's a little bit different code. Okay, and the main difference here is that the coordinate system will be always rotated. This is the small secret that many how is it called, many controllers have, that you don't need to go with a C0, but you need to be a little bit careful. If you, for example, rotate your part before 12.1, for let's say, for example, 45 degrees, as it is in this case, this is roughly 45 degrees, okay? If you rotate 45 degrees, then your coordinate system will be defined in this 45 degrees angle. Now, this is a problem, so I will just run it. And the main difference, what you see here, is this coordinate system here. So let me just rotate it here. So this is an example that we know already so far. And this one, it's a little bit different example where the coordinate system, it's like this all the time. Yes. But what you need to know, you need to take into account this z-axis angle. So what that means, I will try to change one post-processor so you guys see what actually I'm doing. And before I jump into it, I would like to tell you, the main advantage of this. The first advantage is no jerky motions. You go straight ahead to the point that is calculated based on this z-axis angle. The second thing is you can use the G0s because every time it will, the polar interpolation will be canceled and you go directly to the next move. Yes. So also all arcs and compensation are fully supported. Now, the load, it's actually on the post-processor developer who needs to make this calculation. Yes. So the idea behind all these guys is that we need to calculate the H pose set according to this actually next angle. And this is the whole secret. Now I'll show you how actually you can do that. So it will be a little bit of codes, and I hope you will enjoy it. Now, the only downside of this output that I've seen so far, I didn't get any complaints so far, but it is a disadvantage, is that it's not user-friendly. So sorry, not user-friendly, but it's not operator-friendly. So once the operator sees these values, he'll see, okay, how I can read this, how I can modify this. So in that case, it's not, because he needs to go again into CAM and just perform the modifications. But I think that that's completely fine for most of the companies, yes. And just small here, I would like to analyze a little bit this code. So we'll have approach of X something 31, then we will turn on the polar interpolation, then we'll go with G41, and then G1, and X something, Y something. As you can see, C is 0. So in this case, the C will be absolute 0 because the Y is 0 here. Then I would like to come over here. As you can see, if I go down with my mouse arrow here, the Y-axis will be positive. So that's why we're receiving this Y-axis a little bit here. And then we are going to this line over here, which is a little bit on the Y on negative and a little bit on X. So this is what we are receiving. Yes. What you should know is that it depends from control to controller and settings. This angle, how you calculate it, it's something, it can be positive or negative. Okay, I will also talk about that later. But also what is important is that the x-axis can be also doubled, or it can be, which means it's a diameter, or it can be also radial. In most of the cases, I've seen the radial, but in this NTX 2000, that will be my example, it is actually doubled. Okay, so all the x-axis that you see, they are actually doubled. Yes, I'm receiving the question from Goran, and yes, this is what I've mentioned. He said that it would be better to disable the G12.1 before going into the next position. So let's see how to actually to do that. All right. So what I have here is the COM part, the same COM part that I've seen, and we have the same profile over here, so we can all of us analyze it. And before we start to modifying, let me just go to that particular job. I have played with this a little bit, so I'll just remove those. We'll need them later. And I have this simple profile, okay? Nothing so special. Yes, so I'll just double click here. And you just need to go to the motion control, turn the fourth axis, make sure it's phase. Now, is it a polar or Cartesian? I've seen this in many countries. In many countries, it can be different. Yeah, in the literature, you will see it's polar interpolation. But I think that it's my opinion, but the polar interpolation output is something a little bit different. The Cartesian is the one that we are talking about. So when you want to turn out 12.1, and if the post it's from Europe, in most of the cases, the Cartesian will actually be 12.1. Okay, so you better call your local support, to check which one will be actually 12.1. Okay, so this is the Cartesian, and I'll just go to a post itself. And let me make it a little bit bigger so it's also friendly to you. I think this size is enough. Okay, so what I'm searching is for 12.1 inside the post. Okay, so I know it will be a little bit difficult for you because this is the post that you've seen for the first time in your life. But I will show you how it is in most of the posts. Okay, and you will find similarity. I'm sure of that. And you will see what actually I will do and what are the steps that you need in order to modify this. So there's some here variable that it's called 12.1, and this is just the variable that have this value in order to print it correctly. Here we have a Cartesian feed that we will not need anymore, and this is just the comments, and this is to turn it off. Now I'll try to search for this one, and what I'm seeing here is we are inside the phase interpolation. So there is a procedure that it's called phase interpolation, and it has this bunch of the code. So basically like C0 going G28H0, go to the mill turn mode, we have the preposition here. We will print out this polar interpolation, and the cycle will be active as a flag. So this is basically what this procedure is doing. Now, I would not like to go out from this procedure, so I will just make sure that I have split it to the right, so I have seen the two codes, so I can move it left to the right and focus on another code. What I would like to see is where in this post this procedure is used. As I mentioned earlier, it will be in start of job if you follow the presentation, and here we are just making sure if it's a phase or if it's a Cartesian, go to the phase interpolation. Now I'll go up where straight ahead a lot, and then I'll see that it's coming from start of job. Okay, so again, go there. It is here. Okay. This is the only two places where we have it. Now we need to see where is the 13.1. And 13.1, it's only here if our interpolation cycle is active, just the 13.1 will be actually printed out in end of job. And another procedure that we will talk about that today, it's the line 5 axis. We have here, if it's not a 5 axis job, and if it's not a Cartesian, it's here. So as I said earlier, it's just the H pose set where the Y axis, it's printed as C axis. Okay, so nothing so special about this code. Okay, so what we will do, we will improve this 12.1 in this webinar. We have also the move 5 axis. The move 5 axis here. And inside the move 5 axis, we have very similar codes, nothing so special. Again, we have here, the XH pose, ZH pose, and YH pose with the same formatting. Okay, that's all. Sorry, that's not all, but we have also the arc 5 axis. And I think it's very important that I also talk about arc 5 axis. The arc 5 axis for the Cartesian, it is very necessary, especially in the case when it is allowed in the VMID. Let me show you this. This is also very important. So if you open your VMID, guys, and go to the controller definition, here you will have arc execution definition, and here you will have a lot of parameters. Now, if you want to allow user to have an arcs in this interpolation, you need to set this 5 axis arcs on phase, and it must be set to yes. Otherwise, if you put to no, all your toolpath will be with G1s, So it will not be any arc interpolation. But I think for the webinar, this webinar, I think the arc interpolation, we can take it into account as well, as I think it's very important. Let's go back to the arc 5-axis. And what we have here is nothing so special. We have one if statement in the case when it is Cartesian, and in the case when it's not. Now, when it is, we have some code for the if it's spindle, main, or sub, what will take the direction. But again, we have very simple, H-pole set here. And in the case if the arc size it's 360, or in the case when we have the helical, then we need to use the center relative, okay? Or otherwise, it will be the radius. Now, regarding to the helical, you can also turn that on and or off inside the VMID settings. But still, on this webinar, I decided I want to show you all. All right, so from where we will start it, I would start from this phase interpolation, as I want to completely remove it from the starter job. I want actually to be everything inside the move, line, and arc 5-axis. It's completely all what you need for this. So I will just again split it to the right, and I want to go to the end of job, and I want to improve this interpolation, as this is for turning it off, and this is the procedure for turning it on. I can put actually both of those inside one procedure. So in order to do that, I'll just put the arguments here, which will be, it can be logical, and I will call it on, off. On means 1, off means 0. So if I want to turn off the phase interpolation, so if I want to turn it on, it will be all this code here, and it will be true. Else, it will be, I can put all of this, but it's actually not that necessary. So let me just fix the indent like this. I don't need this empty space here. And I'll just type here and if. And as we have here also for the radial, it is actually not necessary. So I will just remove it. And I don't need to change the G code here. I want to make it more simple, as I will do just a second. I'll put just end interpolation here, and then I will just make a formatting. I'll just say it's G code formatting of my code. Okay, so I didn't do anything so special so far. I just say if it's on, just go and run this, and if it's off, just go here. That's all here, except that here if it's true. Now I want to make sure that if it's on and if it's active, I don't want to print it. So if it's not active, so this means not active. So if it's not this, it's not active. Well, you can also call it like this, equal false, or if it's not equal true. Okay, but you can use both of these, or you can use just not equal true. So if my cycle is not active, please make it active. Okay. Okay, this is the first step. Okay. Nice. So phase interpolation. Copy. Let me find where this phase interpolation is. It's here in the start of job, so I'll just turn it off. I will not remove it. I'll just leave it here as it is. And inside the end of job, yeah, end of job, I say that I will turn it off. I'll just turn off here, this one. No, I'll actually turn off everything here. Just this webinar, I think I can do that. Right. Now, where I want to call the phase interpolation, let me copy this, and let me just move this to the left. So I hope you can still keep focused. I'll go to the move 5-axis here. And here we have, if it's not equal, so this is not what I'm interested for, but I'm interested for to see this one. So in my move 5-axis, I will every time like to have a G0s. Okay, I would not like to have my cycle. I will never have a cycle here. I would like to turn off the cycle whenever I'm in rapid move. So this is what I will actually write here down. So I will just phase interpolation, and I will want to make sure it's turned off. So this is how to turn off my phase interpolation. And once it's turned off, I would go with G code, and instead of H pose, I'll just write O pose set in this case. Of course, without formatting of this, I will take the Y pose and maybe move it to the right side as the second axis and just fix this. So this is my phase interpolation. So I'm just turning it off and preposition it. Now, if I want to make a preposition, I also need to make sure that I print the APO set. So also I will just print here APO set. That's all. Small break. Okay, enough. Now we have the phase interpolation in move 5 axis, and we are still not done. So I will go now to the line 5 axis. The line 5 axis is the procedure which indicates that I'm in the cutting, okay? And it means that I want to turn on the cycle. So I'll try to find the same if statement, and we are over here. And the first thing what I want to do is to call phase interpolation and to make sure that it is on. And if it's active, this procedure will be ignored because I said only turn it on when it is inactive. All right, and now we are coming to the main case. As I said earlier, we need to recalculate our values according to the next, I will call it, or you can call it the Z-axis position, okay? Now this Z-axis position, in this case, most of the military machines, the Z-axis is around the Z-axis, okay? As you've seen in the example of the drawing that I shown earlier, we will rotate our part around the Z-axis. And now we just need to take that angle and change the value of this output. Now, how to take this math, okay? So you can do it pretty easily with SolidCam. If you go to the help file, and if you go over here, you will see SolidCam help files and topics. And when you go to the GPP tool, here you will see for this old version, as I said earlier, but the new version will be available very soon. But what you can do, you can go to the search and you just search for the T matrix. This is pretty old procedure, but here we have a very nice formulas that you can use in anything, basically, if you want to rotate your coordinates around specific axis. And if you go to the very bottom, here you will be able to find all the formulas that you need. And it is around Z-axis, Y-axis, or X-axis. And you can just take these formulas. This is the basic ones, and you just take it, copy. I'll just take it here and just paste, yeah. Of course, I will not use this for my code. I'll just want to use this so you can all see what I'm doing. So the next thing what I want to do, I want to create my new set because I don't want to override the system values. I want to create the new ones. So I will just create a local numeric, and I will call it XH pose. Why not? I can do that because this is completely new, and I can do the same thing for the it's my local coordinates. I can do the same thing for the YH pose. Okay, and this is the only two that I need because for the Z-axis we are not rotating anything. The Z-axis will still remain the ZH pose itself. I don't need to change that. And now what I need to do, I just need to perform this new formula in that. So I will just say it here that my NLH pose, it's connected to my H pose, multiply by the cosinus, and then the angle. Now, which angle we are talking about? We are talking about the angle that we perform in the move 5 axis. So when we rotate a part, we would like to take exactly that angle, you know, and rotate all our coordinates according to this angle. Now, where we did that in move 5 axis, right? So in move 5 axis, I will just jump there very quickly. You probably remember that I put here this A pose, okay? Now I need to save this value. Now I'll go here on the top and I will declare a new variable. This will be a global variable because I need it also to use it in many procedures. I will go and create here this what I wanted to show you. It's like a global numeric, and then I'll call it. It's an array because it's according to the channels. And I will call it. How I'm gonna call it? I will call it Cartesian. Yeah, Cartesian angle. And as my machine have 2 channels, each channel can have different angle basically, then I create an array. Now what is very important, why create it in the new line? Because I just want to show you this, guys. I'll just make here and I will just leave the comment next angle for calculation of new H pose for 12.1. And once you save this and you move your mouse over the variable, he'll give you an info. This is so valuable when you go, to the bottom. And also he said that it's a user variable. Okay, so now I will take this one and I'll go back to that move 5 axis. And here we are. We are here in the APO set. And what I'm going to do, I will just say that this angle that I just did it for my channel ID. By the way, it can be also turret ID. Depends of how sensitive this parameter is. Okay, because of many Milter machines, especially Swiss type machines, the G12.1 and this angle behaves differently on each turret. It can be also on each turret, but it can be also different angle for each tool. Okay, so it's really up to you and it's flexible in that way. And I'll just call here APO set. Okay, once I define this, I will just move this to the left and I'll just type here now cosinus of hold this. Again, move it to the left and put it here. And then I put like minus, then we have y, h pose, and then we have sinus, and then the angle, and then the same angle. I will duplicate it, and I'll just change the letters. So this will be x, h pose, sinus, and this time will be plus according to the formula. I'm just looking at the formula. I'm not doing anything special. And this will be cosinus. Done. And of course, here, now I want to use this one. And for this, I would like to use this one because it's new y and h pose. Of course, make the formatting. This is, I think, very important. So make the x h pose f, and this one already have it. And my zh pose is the system one, and it's already declared. So I don't need to really force the formatting in this case. Right. Now, as I finish with this, I can basically remove it. So it's not that difficult. As you can see, I finish it completely, everything what I need to do within the line 5 axis. The things are already done, except in the case when you actually want to make the arcs within the arcs. So I will just copy this and I'll go to the arc 5 axis. And the same thing I need to perform here. So I will not do anything so special. I just paste it. Of course, what you need to do, guys, here very carefully. I forgot to declare it. So I will also now make a local numeric. I can also copy that, and I'll just make this and that. Now this thing already works with the arc and line completely fine if you're using only the radiuses. Okay. Now, if you're using the XH center relative, in this case, guys, you need to rotate that as well. But it's not the same formula. You cannot perform the same formula because this is a relative coordinate. So if you rotate everything, you will get the relatively again, and this is not according to the new position. So I think it's very important that I show it in this webinar. I maybe you will get confused. That's completely normal, guys. Okay, but I would like to show you. First, what we need to have here is the new set of numeric stuff for getting actually the start point. The start point of the arc previously, before we actually start with the rotation. So we want to get that. Pardon. So I will just call it, I don't know, start arc X here. And this one will be the same thing for the Y. And then I also need for a center point. So I have the start, but I need also for the center point, okay, of that. Once the center is rotated, once I have the center rotated, I can roll in and calculate, the next XH and YH center relative. So in this case, I will just call this center point, center arc. Yeah, why not? And then we finally get, the center rel. So I will just call the center relative. Again, I can comment here and it will display everything correctly. Right, now how to calculate all of these, guys. So let's start with this. Nothing so special, pretty much the same formulas, just we'll have 2 times more. The arc, this one would be the same formula. I'll just basically, guys, why not? I'll just copy this. I'll paste it. And I'll copy this. And I'll copy this. And instead of HH pose, I need this. I need my XH center minus XH center relative. And this is for my X component, which I will basically do the same thing over here. And then I know this is a little bit advanced. Don't think that I actually did it from the first. It's pretty advanced that you need to do it, but that's why we are making the webinar, so you don't need to waste the time, guys, on this. So you just take this code and it will work on any machine. And then once we have the arc center, we can also get the center point of the arc. I can basically copy this. Again, just copy. And then I will just take the XH center itself. So I just remove this thing. Not from here, but from here. Exactly. And now finally, we get the center relative here. We can basically calculate it, that this one, it's equal this one minus, oh, sorry, I just forgot that this is center arc and this is the center arc. So it's basically how we are getting is the center minus this one. So this minus arc here. And for the Y, it would be the Y component. So finally, now all of this we needed just to get the XH next relative components. Just for the end, we need to just replace those values, guys, and that will be it. So I will just call it XH pose F. A pose here, Z pose, this will be completely fine. This is copy here, paste. Okay, and then we have XH center relative here, and XH center rel F, and this one YH center relative F. That's all. Everything else remains the same. So it is a little bit bunch of the code here, but it brings you, amazing results at the end. All right, so now I can generate G code. We are not still finished, but we are close, okay? I just want to show you where we are now. Here I have this job, so I'll just generate the G code. Let's see, maybe we made some mistake. Oh, something is wrong. Everything is fine. So P1 here, let's see. We have some double codes here, but what is good that we have this angle. We are going with G0. This is all fine. Now we have here some standard codes that we don't need. We have still this F5000. We have twice 12.1, so something is wrong there as well. And we have here G1, and it should be G0. So let's fix that. I'll just fix that pretty quickly. So first, let's go to phase interpolation, go to definition. What we don't need here. I can leave the home printing the work offset, main back. I will leave it, but maybe we can remove this. I don't need mill turn. I don't need to go to with the C0. I don't need the next position. I can leave G0 here. I don't need Cartesian feed. I will not save this. G code will be start interpolation, so I just start interpolation and use the G code F. This is what I forgot. And the G code will not be printed out here. It will be like that. Okay, and this is printed correctly. Yeah, let me see how it looks like now. Our G code generate. Okay. Okay. I'll go to the P1. Okay, I see something much better. So we are receiving the Z. Maybe I have some double code on the starter job, but that's something that we can ignore now. We'll go with G0 preposition within this angle, and we will turn on the polar interpolation. We have here G0. That's actually pretty bad because we should have G1, G0, start polar interpolation. I'll just change here to G1. I think that's the case. G code generate OK again. Yes. Yeah, that's better. So, and this is how it looks like, guys. Nothing so special. Okay, we have the G3, we have the compensation. Everything works fine, except that now we have some strange values here. Now, you probably remember, I will go again to the move 5 axis. And you probably remember that I create this variable and I say it's a pose. Now, I also mentioned that this can be different from spindle to spindle, from machine to machine. It can be different on the turret level. It can be different on tool level. So guys, in most of the cases, in 95% of the cases, I realized that it depends on the parameter settings, and in most of the cases, it's minus a pose. So wherever I rotate my a pose, if it's on the table, it will be rotated for the negative degrees. And how I can know this, as you can see here, you can test yourself, because the X next position, it's some different value. And it's because the coordinate system is rotated in another direction. So if I now generate a G code, and I go G code and generate and click OK, and I click OK again, then you can see my next X position is the same value as it was, and my C is 0. So in most of the cases, guys, this is the right output. Okay, how you can actually test this? This is the right question. Okay, because now you are getting some strange values, and how you can actually test this on the machine. There are 2 ways, and I will just give you small advices. The first, try with some very simple geometry. Even though this is very simple geometry, you can also test it, but try with something very simple, like a square, and try to see how the machine actually rotates the Z-axis, okay, in which direction, and make sure that this is actually done correctly. and then you go towards the most complex one. Another way that you can turn off the arcs just temporarily in order to see what are the coordinates. But what you can also see, I can take this -52, and what I prepared for you guys is that you can take the sketch of this profile, and you can just make a sketch and rotate it around the point. So you get something like this. And now you can take, you can see the coordinate system, and you can take the measurements, and you can measure each point, and you can see if it matched regarding to the G code. I hope I give you a little bit on that. Now, about the advantages. Advantages are enormous. So first of all, here, this is very simple. Let me hide this sketch first. Okay, the first advantage is, what if, I'll copy this and paste it. What if I want to not make only single geometry? Let me create a new one. If I don't want to make a single geometry, but I would like to make more geometries within the same job. So for example, I would like to start like this, then accept. Then I would like to make this, then accept. Then I would like to make this one and accept. So it's 3 different. Oh, let me add another one. Let's say maybe this one and accept. Now within these 4 profiles, we'll have a rapid movements. And the rapid movements, let me turn off the previous job. And the rapid movements in the previous pose will actually generate with a G1 with unnecessary G0 movements. So it will be pretty, let's say, I would say jerky motions, but it will be like many unnecessary movements, yes? In this case, it will go straight ahead, towards the next point. And let me just generate the G code, and let's see the output. I can also show here with a ISO. Maybe it's better, I don't know. Okay, so as you can see here, we having with the first line, we have this thing. Then we are going to the reference. We are rotating to the next angle, going to the Z2, turning on the interpolation with a new angle. As you can see, the X positions, in this case, this is completely the same because here we have it here, but the next here, X, Y, this is same. Oh, this Y, it's not the same. We have here the arc in the one we should have an arc. Yeah, here we have an arc. Because of the very next, every time we are taking the new value of the C-axis here. In this case, it's -78. In this, it's 127. In this, is -142. So, and every time we are turning on and off, making sure that polar interpolation is turned off within the rapid moves. I hope I give you a lot of new information, how you can handle a post, generally how I'm editing the post, and show you this amazing feature. And hope you have some questions. I have seen this. Some of the questions are here. Questions? Oh no, this is the same question that it was. Yeah. All right, and I know it's already pretty late, I would say. Sorry for the long webinar, but I would like also still to continue to the coolants, as it will be a much shorter topic. But I will also talk about implementation of coolant options. A few things about it. I've seen many solutions inside the post. Okay, many. I would not say that some are better, some are worse, but I pick up one of the very that I really like, and that you can also use it. I've seen also many posts that actually don't have a full control of the coolants. So I think it is very important that we also mention the coolant options in this webinar. So I'll just show you what is the code for it, okay? And I give you now the code, and you can basically copy it and paste it. Now be careful, as I said earlier, copying, from the presentation will will make some characters invisible or maybe wrong, and it will generate, the errors inside the G-code generation during the G-code generation. So be careful. But the main thing is that I will just show you, how you can implement the coolant. Now, in this post, the coolant is not implemented, so there is nothing about the coolant. And I will show you how you can add infinite number of the coolant options, not infinite number, but all coolant options that your particular machine has. Okay. So let me go to the post itself, and what we need to do first. First, we need to allow the coolants. Okay. So over here, I have one job, and here I have my tool, and I can go to the coolant. As you can see, I have no coolant options available. So the minus sign here means no coolant. Okay, no coolant is possible to define. To allow coolants, you can go to the VMID, and you can go to particular device. You can do it also on the machine level options. You can add it over here. But in this webinar, I'll just show you here for the particular upper turret. And I will just say, I would like to add a flood option and coolant through tool on and off. And those will be the one that I would like to show you. And I'll just save and exit. And what is the main difference in the interface is that now you have an option to add a flood and a through tool. So there now you can activate one of them as it is a third coolant. Right. Now, what I've seen so far in many posts is that that you have a specific procedure for turning it on or off. Okay. What is very specific in this code is that everything what is coming in or out, it's within the same procedure. So that's why is it great, because you can copy the same stuff and move it to another post. It's not only relevant to the mill turn multi-channel machines, but you can use it also in the milling post processes. So I will just start with this thing. I will just duplicate here, and I will add it like this, and I'll call it like with the standard coolant, and I will just make an integer here, and I will call it on off. Very similar to the previous example, because this means either I want to turn on the coolant or I want to turn it off. This now doesn't necessarily mean that the coolant will be turned on or off. So I'll explain it. And just now I'll just go to the end P. Now for all of you, I want to show you one thing. I will go to the trace 5 and just explain you how simple this problem is, but actually how difficult once you start to think about. I will just go to the start of job. Yes, but I would like to do it in this case. And I will change it to white. Okay. So inside my start of job, at the end of the procedure, I do have here a bunch of coolant options: active, non-active, or not even with action. And this means no action means it's 2, off it's 0, and 1 it means on. And what you need to know is that here it's where you turn it on, and if you go to the end of job, you have nothing but what is the status of about the coolant. So all the active coolant will be turned off. Now, what is the main problem with this? The main problem with this, if you try to make simple procedure where you will say, okay, if flat coolant is equal 1, print M8. If it's off, it's print M9. It will work, but let me warn you, this kind of things will make if you have 3 same operations and all of them have the coolant option active, what your customer will see is turning on and off coolants all the time. So after each job, he will turn off the coolant. So this is something that you don't want to see. Okay, and because of that, we need to create a special variable that will save the value of my active coolant, and according to that, we will actually print it on or off. Okay, so how to do that? Very simple. I will just take this procedure, and I want to go to start of job. Here I have it, and what I want to make sure is that I call the coolant, and I want to make it off in the case when it is not active in the current operation, or at least it was active in previous operation and it's not active in the current one. So this is where I want to print it on, and then later on when I decide, let's say after all rapid motions and the stuff, let's say that after the feeds and spins and all those stuff, maybe here before the 5-axis, maybe here, I would like to just print the coolant 1. So if it's active, just turn it on. The conclusion is turning on and off coolants, the status, everything is done within startup job. Everything. I'm not taking care of what is in the end of job because I don't want to turn it off. I want to make sure, I want to check what is within the next job. Okay. Now, I'm not saying that the next code that you will see is the best one, as we can improve it more and more, but at least it will cover 95% of the cases, you know, that you will have. So let's go to the procedure here, and I'll try to write it very simple. First, I said earlier, we need to save a status about which coolant it's active or not. So I will go to the beginning and I'll just declare the variable. It can be, it will be an integer, or sorry, it can be not the integer, but the logical, if the coolant is active or not. So it will be an array, and then I will just call it coolant active, and it will be an array. That it will be 2-dimensional array. It can be also be 3-dimensional array depending of for what machines you want to do. But in this simple example, as it's for the multi-channel machine, my particular machine has only 2 turrets. Okay, but you can make, let's say, supporting it by the 10 channels, for example, or 10 different turrets. Okay, so for each turret can have different types of the coolant, and I can save the type of the coolant. The next is how many types of coolant you have. In practice, I actually see for each turret that they have 1, 2, maybe 3 different coolants. Yes, but if you want to make sure, you know, just you put 10, and it will be completely fine. Just put the number enough, you know, for your type of coolants. In this webinar, I'll just show you 2 coolants, the flood one and through tool. So in this example, it will be 2 will be enough. But you know, for the future, it's always important that you look in the future that you can put more coolants if the customer bought or extend the options on the machine. So what I want to do right now, I'll just go over here and just start typing the code. So I'll check. There will be basically 2 if statements or 2 conditions, this one or this one. This means if it's active, sorry, if I want to turn it on and it is not active, please print it. And this one will be if it's off and it is active, please turn it off. Pardon. Okay, so how to do this? So it will be this variable, as I said, if it's on, and now this is the main part. You need to take the system variable that we are checking if it's on or off, and we have the flood coolant here equal 1, and if my this coolant active or coolant status, actually I think I will call it coolant status, it will be much better to understand it. If my coolant status about that one, in this case I will call it in channel ID, as I do have 2 turrets, but in the cases, guys, that I show you here in the presentation, it's about turret ID. which will be completely, how should I say this? Which will be completely correct. But in this example, I just used the channel ID. And the tool type, the coolant type, it's just the first one, as we didn't define more than one. So let me just turn off this. I will not need it anymore. So we get a little bit more space. So if it's not active, and if it's one, and if coolant is one, we'll go to this condition. But if this one, it's equal 0, and this one is particularly active, turn it off. If it's active, and this is if it's not active. Perfect. And then the end if, and this is basically my whole condition, guys. What I will do here, I'll just type here. You know, for the flood coolant, we'll make like flood will be M8, turning off with M9, and M9. Sorry, M9 again, M9, and then through will be M7 and M9, just for example, okay? And here I will just type very simple condition, 9 minus, you know, if it's on and off. So if it's 1, it will be 8. If it's off, it will be 9. So simple, right? And then I will just format it. So M code F. And that's done, guys. So it will automatically print M8 or M9 accordingly. So let's test it very quickly. Here I have 3 jobs. Let me create another job here. So these jobs are equally the same. Let me create another one because I want 3 same one, not different one. So we see enjoy these. And within this one, we'll have flood on. Then I would like to have again flood on. And then I would like to have flood off perfectly. So what I will see here is the M8 and M9 should be at the end of this one, or I can do it a little bit different. Sorry, I will turn it off here and turn it on and here again. Let's see how that will work. Go here, G code generate. All right, P1, we go over here. Let's see where it is. Here we go. We have M8. We have the next job. Where it is. Did I forgot something? I think I did. I think I did because I don't have M9 in this case. So let me see the code here. If it's equal and coolant status, it's active. Oh yeah, very important thing is I didn't change the coolant status for this one. So my coolant status will be actually the status that I have here. And now let's try it again. It's good that I make a mistake. In one moment, I thought that I didn't make any mistake. Yes, let's go to the P1. And now we have the M9. So we have the M8, we have the M9. This particular job doesn't have M8. And then we will have, again, M8 here. I hope you like it so far. Now, I will show you how we can add actually through coolant here. So the only thing what you have to do is just to paste it. So as more coolant you have, you just copy and paste and just replace this. So I'll just call through tool through coolant status. This is my second type of my coolant. So I'll just change here to 2. Of course, guys, this can be very much improved. Now, what I have here is one particular example where I have through tool. When it's active, it's M7. So how to do it with this one? I can't do it because if it's 1, it will be M8. It will not be 7. So for this, we need to add a correction. And the correction will be just like a local integer. integer, where I'll just call it corrector or coolant corrector, however you want. Corrector for M code. And I'll just copy this. And now for in the case of this one, I can basically type if on off equal 1, or if it's just active, my coolant corrector will be -1, and then end if. And then I need to add this corrector here. So basically 9 minus 1 and -1 will be 7. And if it's 0, it will not go to this corrector, or I can just make else. I can say it's equal 0, then it will be 9. Now let's test it. For the last operation, I'll just make a through tool and just generate the G code. I'll click OK. And now instead of M8, we have the M7. And at the end, actually at the end of program, I could add, also the coolant off, just to make sure that all the active ones will be actually off. So I can also add that, but I will not do it because you already got it, guys. This condition can be also more improved. If one M9 it's called, then turn off the status of others, and you can also, some controllers can have only 4 M code in one line, so you can basically, guys, create a new block after 4th M code or coolant. So this is something that I don't want to show you here. I considering you very advanced post-processor writers as well, and I hope you enjoyed this part 2 from good to great Miltern post-processors. I hope you enjoyed. I hope to see you to the next one, the part 3, which you will be also shorting for. As with others, this one it's also recorded, and in a few days you can expect it to see it on the website. I have a few questions here. What makes okay? There is some questions that are related to the basic ones, so I'm calling you. If you're interested to see the basic ones, feel free to call your local reseller. They will give you, the videos towards, the basic course that we have recently. And so the questions like, what is the difference between the postal machine? Yes and no, it's not related to this webinar. Thank you again for watching, and see you into the next one. Bye.